Hello, my name is Brandon Enright, and this is a quick video tutorial of how to solve the Dino Dodecahedron. This is Gelatinbrain's 1.2.1. Some people call this a star minx or like a dino star minx or something like that. As you can see, it has the same pattern as the face turning or the edge turning or the vertex turning star minx, but this puzzle is shallow cut, so you can see that hardly anything turns at once. This is an exceptionally easy puzzle. Really, the only tricks to solving it sort of come at the very end, solving the last face. But even then, it's pretty straightforward. This is pretty similar to the Dino Cube. I would say that the only difference, well, there's essentially three big differences between this and a Dino Cube. One, there are these 3 points, I call them a vertex, and these three triangles are attached to each other. So even though you can move an edge, you can't move these three triangles. And so these show the orientation of each vertex. And so you can do something like that. And so what we've done is we've three-cycled these three triangles around the vertex, or if you turn it that way, then we moved the triangles back, but we changed the orientation of the vertex instead. And so that's similar to what you get out of like a super Dino Cube. And then the other big difference is that on the Dino Cube, the edges can only be in one orientation per position. So if this is the white-green edge on a Dino Cube, the white-green edge would always be in this orientation. But as you can see, if you take it around in a circle here, then we just changed the orientation of the white-green edge. Granted, we broke a bunch of other stuff, but you can change the orientation by just sending something around in a circle. So the way I would suggest you solve this puzzle, well, so you can make a 1-1 commutator to three-cycle three edges, and again, this works because with a commutator, you're just looking to isolate a piece, and as you can see, two adjacent vertices overlap by a single piece, and so it's just trivial to do that, a 1-1 commutator, to do a three-cycle. So this would be the x part one move, y part one move, undo x one move, undo y one move, for a total of 4 moves. And as you can see, it changes the orientation of two pieces while you're doing that. And so the other thing that you can do on this puzzle, and this is very similar to the orientation changing commutators that I've demoed on a number of other puzzles, is you can change the orientation, you can flip two pieces. So again, like most other puzzles, twist is preserved, at least in the edges, as you can see from this move that twist is not preserved in the vertices. And that makes sense because turning a vertex just does a three-cycle in the edges, and we can do a three-cycle of pieces. So so if that did a three-cycle of those pieces, and we somehow arranged it so that the other piece that got cycled, so let's do something like, well, so let's do that, okay, and then undo. That was just a bunch of setup moves there. Okay, and so again, we just changed the orientation of a vertex via a three-cycle of the edges rather than this sort of magical 8-move sequence. But anyways, the other thing you can do is you can change the orientation of the edges, and again, because twist is preserved within the edges, you can never have a single edge flipped. You can only have pairs of edges flipped. And the typical way to do that is you isolate a piece, just like always with commutator. So we've isolated this green-white piece, and then we're going to do something to it, and then we're going to bring the white-purple piece back in its place, and then we're going to undo that. So this is the x part. Now we need to flip the orientation of this green-white piece. So we saw how to do that. It's basically just take it around somewhere. There we go. So now we've changed the orientation of the green-white piece. Now we got to undo. So we just undid. So all of that was the y part. Now we're going to undo the x part. Now we need to undo the y part. There we go. And so it's an orientation changing commutator. This was 14 moves, so X part was 1 move, and then the Y part was 6 moves, and then we undid X, and then we undid Y, and it came out to be 14 moves. There might be a shorter sequence to do that on this puzzle, but I haven't found it. So the way to solve this puzzle is the core is fixed. So these centerpieces here, let me show that to you. So these centerpieces are fixed. So you just solve to these centerpieces, which obviously you can't move them. So just if you want to solve like top down, just find here's the. I'm going to fix the orientations of the vertices first. So here we white, purple, green, and so now I'm looking for like a white. Here's the white blue piece, and it needs to go right there. And so I'm just going to literally like do that. Oh, okay, we got its orientation wrong, so we need to take it around this puzzle. There we go. So let's do it with. Okay, so now it matches up with it. Anyways, you can just solve the entire puzzle top down. And what you're going to get when you get to the very last layer, so let me show you what that would look like. I'm just scrambling here. I'll show you how to solve this last layer. It should be very intuitive. I suppose that's sufficiently scrambled. Okay, so first thing I'm going to do is I'm going to solve all of these pieces, and I'm going to try to do so while maintaining the orientation of the vertices. So the yellow-blue piece, no, okay, so we need like the pink-blue piece. So there's the pink-blue piece, and the pink-blue piece needs to go like that. Okay, and we got its orientation wrong, so we need to bring it around. Okay, we need to bring it around like that. Okay, now, so the pink-blue piece is solved. Now we're going to do the red-blue piece. So, nope, doesn't match again. So we need to bring it around. Okay, we do that. Okay, now the red-blue piece is solved. Now we need to do the red-orange piece. Again, okay, the orientation is right that time. Okay, now the green-orange piece, and the orientation's wrong. So we need to bring it around in a circle again. Okay, and then we need to undo that damage so that we undo the brokenness. Okay, now the only thing that's left here for this last little piece is the pink-green piece. I thought I already solved that. Maybe I did. Maybe I broke it accidentally. Okay, so there we go. So now we're down to this very last layer. What I'm going to do, I'm going to try to solve this. So we'll solve that blue piece right there. Okay, so I was just paying attention to one piece right there. Now I want to solve, okay, the red piece is already solved. It's just the wrong orientation. And now let's solve these three pieces. So as you can see, if this piece goes there, and that piece goes there, and that piece goes there, that'll take care of it. So that this is the commutator to do that. Okay, now we have two pieces, their orientation is flipped. Because they're not adjacent to each other, let's just do a little setup move like that so that now we can replace them with each other. So, okay, now we need to flip the orientation of this red piece around. Okay, and now we need to undo the orientation flipping for this pink piece. There we go, and then we undo our setup move, and puzzle is solved. So this should be a very easy to puzzle. I forgot to add, this puzzle actually exists in its physical version. MF8 / I believe Dan made the Dino Dodecahedron. I think it's like $28. It's a pretty easy puzzle. In my opinion, it's too easy to actually be fun. But there you go. You should be able to solve this entire puzzle now.